So what we're going to do now, we're going to look at types of experimental design. So in general, what we're going for is when we've talked about sampling, and sampling is how we select people from the population to be in our sample. Now we've got our sample, how do we assign treatments to the people in the sample? Again, we want to try to use randomness. Just like we used randomness in putting together our sample, we want to use randomness to put together our experiment. So what we want is a completely randomized experimental design. Just like we put our sample together using probability, we want to do the same thing here. And again, it's to avoid things like bias. We want to stay away from that. So let's see. Generally, the form this takes is assigning subjects to different treatment groups or a placebo group randomly. So basically, we're going to assign people to these different, the treatments they're going to receive. We're going to do this randomly. We're going to, again, rely on chance. So we have some designs here to take a look at. So one kind of design, and we just kind of mentioned it, I didn't point it out as a design, but you could think of it as that, is this completely randomized experimental design. Basically, you have your sample, and then some people randomly assign the treatment, some randomly assign to placebo. All right, this is a slightly more complicated design. So this is kind of our second design. So what we're going to do, we'll form blocks of subjects with similar characteristics. So this is very similar to when we did stratified sampling. In stratified sampling, what we did is we took the population and we put it in the strata, and each strata contained persons or subjects or maybe individual units that have a similar characteristic that's relevant to us. And then we sampled from this strata, sampled from this strata, sampled from this strata, and then those subjects or those individuals we sampled, they become part of our main sample. And we don't pick everybody. Remember, in clusters, when we, divide the population into clusters, we randomly choose clusters and use everybody in those clusters that were chosen. But in stratified sampling, we just divided the population into strata. Each strata has basic people the same characteristic that's relevant to us. That wasn't the case with clusters. And we still sampled some people from the strata. Well, that was for building a sample. Now we're doing an experiment. And this is the same idea with experiments. And so what's going to happen here, we form these blocks, again, persons with a similar characteristic that's going to be significant to our study. And then we will apply all the treatments or a placebo to each block is what we're going to do. So each block excuse me, each block receives the treatments and or the placebo. So an example of this, let's say we're testing some kind of drug. And for whatever reasons, blood type is a concern. It might have some kind of influence on how people respond to this drug. And so what we do is we put people in blocks based on blood type. So these, now keep in mind, these are persons that have already been sampled. They're part of a sample. We had our population, we came up with a sampling strategy, and now we have our sample. With the sample, we divide that into blocks. So there's going to be a block of A positive, a block of A negative, block of B positive, block of B negative, block of O positive, block of O negative, block of AB positive, block of AB negative. And so what we're going to do, let's say we're going to test this one drug, and we're going to have a placebo. So what we'll do in each block, randomly assign the treatment, in this case our drug, and the placebo. And this is in each block. Each block will get the same drug and the placebo. Drug and placebo, 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 drug and placebo. And then well, that's going to be our experiment, and then we'll look at the results. So this is the randomized block design. So we have the completely randomized design where we have our sample, and then we assign some people to receive treatment and some people get placebo. Here, we break everything down in our sample into blocks based on blood types, and then each block gets the same treatments and or placebo. And then we look at the results. All right. Another one, matched pairs. So we talked about, you've got your sample, randomly assign some people treatment, randomly assign some placebo. All right, completely randomized design. Or we could do blocks, different blocks, take our sample, break it up into blocks. Each block gets the same treatments or treatment and placebo. This one's a little different. So what we do, it's used often to compare two treatment groups. So we're going to say we're going to test two drugs. You want to see how effective they are. All right. Well, let's take a look. We break up sample into pairs of persons with similar characteristics. And a great example of this is twin studies. You'll learn more about these throughout the semester. But what we do is we take the sample that we've gathered from the population and we pair people from the sample up. And we try to pair them up with people who have some characteristic that's in common, something relevant. So say from our blood type example, we might pair up two people who have blood types of A negative, and then pair up two people with blood types of O positive, and pair up two people with blood types of AB positive. And so we have these pairs. We just go through and pair everybody up. And then what's going to happen in these pairs, one person will get the first drug or the first treatment, and the second person will get the second drug or the second treatment. So one person gets the first treatment, other person gets the second treatment. And then this is decided like who gets which treatment. Again, decided randomly. So we'll randomly assign one person treatment 1, the other person treatment 2. All right. So an example of this let's say a twin study for Crest versus Aquafresh toothpaste. So what we might be interested in is, does it matter if you use Crest or does it matter if you use Aquafresh? So what we might have are pairs of twins. We randomly, or let me be a little more specific, in each pair, randomly assign one twin Crest and the other Aquafresh. So each pair, say I have a pair, will assign one twin randomly Aquafresh, the other one randomly Crest, or vice versa. And then at the end, compare results among Crest and Aquafresh users. So again, we're bringing randomness into this. So we've talked about beginning for this section, how to put the sample together, again, using randomness. And then we're going to also talk about, as we've been doing, experiments. How do we put these together randomly? There's another method, and it's not a random method. So what it seems to do is it basically says, can you, okay, fine, let's say we're assigning things to, like, we want to test, say, whether or not some drug is effective. And let's say we're going to do a very specific demographic. And the example that one example that's put out by Stats from LibreTex was, let's say you have male full-time students who take only night classes and have full-time job with kids. And so what you do is you divide these similar persons into two groups. One group gets the treatment, the other gets the placebo. And the idea is that, well, if you carefully identify individual subjects, so they're very, very similar, well, then maybe they're so similar, randomness isn't going to be something you need to think about. And I'll give you an outline of what's going on here. Someone carefully, let's see, identifies and assigns individuals with similar characteristics to different treatment groups. So basically you're going to eyeball it. So when you construct your sample, somehow you're able to construct a sample where people of these characteristics are in the sample. Now this might be fairly, maybe not too difficult. Let's say you want to test the effect of two drugs on people who have O positive blood. So, all right, we just need people with O positive blood. And so you get a sample of persons with O positive blood. We're just concerned what this is going to do to O positive. And okay, and so you divide them up into two groups. You get drug A, you get drug B, or maybe you get a drug and you get a placebo, and we see what happens. The issue here with not doing this randomly, it goes back to issues like lurking variables. And the thing about lurking variables, you can't necessarily get rid of them. For example, you might have individuals in this study about blood type and this effect of a drug, and we have a placebo group and a treatment group for O positive people in the sample. The sample is of O positive people. And what's going to happen is that some people might have some kind of stressor that's also going to react unpredictably with this drug that other people don't have. And if for some reason more people with this stressor, like let's say it's heart disease, more people with heart disease are in the placebo group than in the treatment group, then this isn't going to be a very accurate study. The thing is that when we use randomness, it in a way will spread out that lurking variable. If we assign people placebo or treatment randomly, we might have as many people with, say, a heart condition in the placebo group and the same number of people with this heart condition, say it's heart disease, in the treatment group. And so the effects of heart disease will be affecting the results hopefully equally. So that's the idea of using randomness to assign treatment and placebo. In this case, you're kind of just, as they say, eyeballing it. You're just going to take people who you think are very similar as far as you can tell. You might not be able to discern if they have heart disease or not. You're going to put them in these groups on your own, not using randomness, and hopefully you don't stack a lurking variable in one group that's not appearing in another group. So the issue here is we divide And again, there's nothing here in the text that says this is random. You're just saying, okay, they're similar. They're all type O positive. So, okay, where you go here and you go here, and then we'll hand out the treatments or the treatment and the placebo. So here's the problem, is that we can't, it's not easy to tell so I'll go through that example with blood type. So what we would do, say we did a random sample, and we have people with type O blood, O positive in this case, and do a random sample, or a simple random sample. Go for sort of the gold standard here. So you have a simple random sample. And then what we're going to do, in this random sample, all it said is that you have type O blood. And so we just randomly sampled from the population people type O blood. So someone could be like a fitness fanatic and they're doing all this cardiac work and their heart's doing really well. Someone could have heart disease. It could have been something that was congenital, something they were born with. And they've done all kinds of good things to manage it, and they're living a very happy life. And all kinds of different physical conditions, different sort of stages of health, or different ways people maintain their health in this random sample of people of type O positive blood. Now, when we introduce this drug, it might destabilize some of this. So here's the thing. We try to divide our sample in two. I'm going to divide it into two groups and try to we're going to try to force this, both groups, similar to each other. So you already have a group of people who share a common characteristic, and then we're going to divide this into two groups and try to make these two groups as similar as we can. And, you know, if we have maybe, say we have 20% are runners, say 10% are managing some form of heart disease. But the thing is, there could be other characteristics that could be affected by this drug or could influence the effect of the drug that we don't see or we can't identify. Like running, we can just ask people, who's running regularly? All right, who has heart disease, but they're managing it? We can get that kind of information usually, but someone might not know if they have heart disease or not. And there could be some other physical characteristic that a person has with regards to that could be affected by this drug, or might confound how this drug works, that we don't know about and that the people in the experiment, they might not know about. So if we try to actually do this on our own, then we might overlook some characteristics and again stack one side with a lurking variable that's not so much on the other side. So what that might look like this is group 1, we'll call them G1, G2, well, for group 2. And so in this group, we might have, again, 20% runners. Get this a little bigger. Well, I'll just use R. Runners. And then 10% heart disease. And we might be pretty good at this. I mean, we might be able to really make sure that this is the case for both groups. So you have runners, and then we have 10% heart disease. But then there could be some lurking variable that, again, we can't see it. And there could be, like, say, 70% over here. And only 20% over here. Now, what this lurking variable could be, it could be like an allergy to this particular drug that we never imagined, that nobody imagined. And then just so happens that the way we split everyone up, okay, this is balanced, but over here, 70% of the group has the allergy, 20%, only 20% over here do. And so this is going to cause problems in our results. The way we can handle this is we use randomness. We assign people to these two groups randomly, and hopefully using randomness will balance out the lurking variable so it's closer to 50% allergy, 50% in this group have the allergy, something like this. And well, hopefully that'll happen. We'll have to see. So anyway, that rigorously controlled design, it does seem that it could have some flaws, and you gotta be careful. There could be variables that do not make everyone similar. It makes it hard to make the two groups similar. So, you know, if you're not aware of those, that could throw off your results. Well, that's it. Any questions? Let me know.